Hi there, welcome to EudretiX, where we make your high school life simple. I'm Aniket, and in this video we're going to do the hard difficulty problems for linear equations in one variable as part of our Digital SAT Algebra series, Algebra Practice series. Okay, so from here we're beginning with the hard parts. Make sure that you practice at least the hard parts. Okay, so all the hard difficulty videos, even if you've not done the easy or medium ones, because these will be very helpful on the actual SAT. Okay, so make sure you practice alongside. Try the questions yourself first before looking at our solutions. Let's begin. Hector used a tool called an auger to remove corn from a storage bin at a constant rate. The bin contained 24,000 bushels of corn when Hector began to use the auger. After 5 hours of using the auger, 19,350 bushels of corn remained in the bin. If the auger continues to remove corn at this rate, what is the total number of hours Hector will have been using the auger when 12,840 bushels of corn remain in the bin? Okay, so multiple points of information. First of all, initially the bin contained 24,000 bushels. Okay, after 5 hours of using the auger, it's 19,350 bushels of corn remained in the bin. So how many got out using the auger? 24,000 minus 19,350. So this is 0, 5 and sorry. So 0, 5, this is 936, 1394. 4650 bushels were removed in 5 hours. So how many in 1 hour? 4650 upon 5. So 5 times 9 is a 45, 15, 5 times 3 is 15. 930 bushels per hour is getting removed using the auger. 930 bushels per hour. Okay. Now they're saying that if auger continues to remove corn at this rate, what is the total number of hours Hector will have been using the auger when 12,840 are left? So out of 24,000, 12,840 are left. So how many are removed? Let's see. 0, 6, 1, 1, 1. 11,160 bushels were removed. Okay. And let's divide this with 930 to get the number of hours it took to remove these many. 11,160 over 930. So zeros cancel. 1116 upon 93. Let's see, we can divide it with 3. So 3 times 3 is a 9. 21, 3 times 7 is a 21. And 3 times 2 is a 6. 3 times 3 is a 9. 3 times 1 is a 3. 372 over 31. Let's try this again. So 31, how many times does it go into 372? Looks like 9 or 8. 8, 1. Oh no, let's try 12 because it's ending with a 2. So 31 times a 12 is going to give us 12 times 1 is 12, 2 carry 1. 12 times 1 is 12 times 3 is 36 and 1 37. That is correct. So it's 12 hours. Option D. So in 12 hours, 11,160 bushels got removed from the bin. So 12,840 remain in the bin. Okay, just like the question asked. So it's just having too many calculations in this question. You can use a calculator directly to solve this in a faster way. I just wanted to show you each step here. That's why I took this much time to do the calculations. Okay, let's go for the next one. Alan drives an average of 100 miles each week. His car can travel an average of 25 miles per gallon of gasoline. Okay, a gallon is 5 liters. Alan would like to reduce his weekly expenditure on gasoline by $5. Okay, assuming gasoline costs $4 per gallon, which equation can Alan use to determine how many fewer average miles M he should drive each week? Okay, so right now he's driving 100 miles each week. Okay, and his car can travel an average of 25 miles per gallon of gasoline. So how many gallons of gasoline is he consuming? average number of miles per week upon 25 miles which the car can move per gallon. So these many gallons of gasoline Alan is using in each week. Okay, so this multiplied by the rate of each gallon of gasoline will give you the total cost for each week. Okay, the total cost of gasoline for each week. He would like to reduce his weekly expenditure on gasoline by $5. He wants to reduce this figure by $5. So which equation can he use? If he wants to reduce by $5, that means 24. Let's look at the equations. Okay, so it's important to understand the framing of the question, the wording of the question. So in the last line, the saying, assuming gasoline costs $4 per gallon, which equation can Alan use to determine how many fewer average miles he should drive each week? That means they're not asking us the total number of miles he should be driving, but instead the number of miles he should be reducing from the 100 miles, okay, each week. So if you see, like in this expression, this is the cost for driving 100 miles. If I ask you the cost for driving 1 mile, it will be $4 over $25. This much would be the cost for 1 mile. So if he drives some m miles, this would be the cost for driving m miles, 4m by 25. He wants to reduce the cost by $5. So if we equate this 4m by 25 equal to 5, from here the value of m which we get would be the number of miles he should reduce from the 100 miles he's driving each week. Okay, so that means 4 over 25m is equal to 5. This is the equation which we will use to find out the how many fewer average miles he should run each week. Okay, so be careful about the wording of the question, how the question is framed. It could be written in a better way, but then you can also gauge what the question is asking by looking at the options. None of the options shows kind of the total number of miles which he should be traveling, because if you look at option A, it's 25 over 4 times m. First of all, this can never be the expression for the cost, 25 over 4. It'll always be 4 over 25, the dollars over the number of miles. So option C is the only one, and 4 over 25 m cannot be equal to 95. Otherwise, this means they are reducing by the cost by $95 instead of $5. Okay, so option D is the correct one. If there's any confusion in this question, let me know in the comments. Okay, let's go to the next one. 3 times kx plus 13 is equal to 48x over 17 plus 36. In the given equation, k is a constant. The equation has no solution. What is the value of k? So remember what we did in the medium difficulty videos. No solution exists when we get something like 0 is equal to b, some constant, and infinite solutions for 0 equal to 0. So we're doing this one. Let's open the bracket. 3kx plus 3 times 13 is 39 is equal to 48 over 17 x plus 36. So to satisfy the condition given in the question, we need this form, 0 is equal to b. For that, as you can see, 39 and 36 are not equal, so our condition is satisfied. The constant terms are not cancelling each other. The variable terms must cancel each other in order to get this form. So for the variable terms to cancel each other, they must be equal to each other. So 3k should be equal to 48 over 17, or k is equal to 48 over 17 times 3, or 16 over 17. This is a grid-in question. Your answer would be 16 over 17. The moment it is this, the variable terms would cancel. It'll be 39 is equal to 36. And then you subtract the 36 from both sides and you get 0 is equal to 3, which will lead to an equation that has no solution, that has no solutions existent. Okay. For this equation to have infinite solutions, we'll have to do like the variable terms must also be equal and the constant terms must also be equal. So that's not possible in our case, because we can only manipulate the variable term through the value of k. Okay, so that will only change the variable term, not the constant term. So that's not possible in this case. the case of infinite solutions. So overall the answer is 16/17. Let's go to the next one. A certain product costs a company $65 to make. The product is sold by a salesperson who earns a commission that is equal to 20% of the sales price of the product. Okay. The profit the company makes for each unit is equal to the sales price minus the combined cost of making the product and the commission. If the sales price of the product is $100, which of the following equations gives the number of units U of the product the company sold to make a profit of $6840? Okay. So the company needs to make a profit of $6840. For that, it sells U units. Okay. The sales price. So what is the profit? How is it written? It is written as 100 minus the manufacturing, which is $65, plus 20% of the manufacturing cost. Oh, sorry, 20% of the sales price of the product. So sales price is 100. So 20% of 100. Percent of 100. It's written like this. This would be the profit on 1 unit, whole thing multiplied by U. This would be equal to 6840. Let's simplify the equation to see which option it matches. Okay, so 100 minus 20% of 100. I'm opening that second bracket out. Minus 65 is equal to 6840. Keeping the U outside. Now 100 minus 20 upon 100. This is here. So what I can write is, I can take the 100 common, this 100 and this 100 common. So you have 1 minus 20 over 100 left. And then minus 65. Let's solve this further. So 1 minus 20 over 100. This is 1 minus 0.2 or 0.8. So 0.8 times 100 minus 65. Whole thing multiplied by U is equal to 6840. If we look at the options, 100 times 1 minus 0.2, which is 100 times 0.8, minus 65, complete thing multiplied by U is equal to 6840. Option A satisfied the condition. Option C also looks to be satisfying, but it's not. It is doing 0.8 times 100, but the multiplication with U is only happening, multiplication of U is only happening with 65. It should happen with a complete thing like this. Complete thing should be multiplied with the U. So option A is correct. Okay. So this was just about rearranging the terms, nothing complex about it. You first write the exact expression after reading the question, like convert everything into a mathematical expression, and then just rearrange the terms to ascertain which option is correct. Okay, let's go to the next one. How many solutions does the equation 10 times 15x minus 9 is equal to negative 15 times 6 minus 10x have? Okay. For that, we cannot comment unless we completely simplify the given terms. Okay. So on the left hand side, it's 150x minus 90. On the right hand side, it's a negative 15 times 6, which is a minus 90, plus, because two negatives, negative 15 times negative 10x, which is 150x. Both sides are identical. 150x cancelled from 150x, negative 90 cancelled from negative 90. It's a 0 equal to 0 situation. That means infinitely many solutions. Option C is the correct one. Okay. So here we conclude part 1 of the hard difficulty questions. If there are any doubts you're facing, let me know in the comments. Make sure to let me know in the comments so I can cover that in the next part of the hard difficulty problems. Okay. So the part 2 would be out soon for hard difficulty. Stay tuned, keep practicing, like, share and subscribe. Bye-bye. Take care.